Hello guys, so today we will be solving a problem of Norton's theorem only. We have already covered Norton's theorem in our last lecture, but with this time we will solve the problem with a dependent source. So we already have the circuit. You can check. We have a 10 ohm resistance over here. We have a 3I dependent source, voltage source over here. We have 5 ohms resistance over here, 10 ohm resistance over here, 5 volt independent source over here, and one 10 voltage dependent current dependent source, current dependent potential source over here. So this potential value depend on I2, which is present over here in this direction, and this dependent source depend on the potential depend on I1, which is this branch current. So to find the Norton's equivalent circuit, we have to make it like this. We have to find IN, we have to find RN, then only we can make a equivalent circuit. So we have to find Rn and In. Since here directly we can sort the potential sources because these are dependent sources. So how we will calculate Rn is we will calculate both VTH and In. Obviously we have to calculate In, which will be the short circuit current from A to B, and VTH will be VA minus VB, and In will be current from which is flowing A to B. Okay, when we will short circuit these points, the current between A and B, that is IAB, will be Norton's current. Okay, so we will find these two terms and we will divide in order to find Rn. Even if in some dependent case, some dependent questions, if the Rn value comes negative also, then the value of Rn you put it negative and calculate the and give it the circuit. Okay, since you are getting a negative value of Rn, you will also put a negative value in the Norton's equivalent circuit also and calculate the load current. It's very important. Okay, so how we will solve? So first we will take out VTH. So it is VA minus VB. So no current is flowing in this loop because it's open circuit, and here we can assume I2 is flowing in this direction because already direction is mentioned. So I2, let's write a KVL equation at 1. So by KVL at loop 1, okay, we will be having it's 10 I2 plus 5 I2 plus 10 I2. It is a potential source, mind it, minus 5 equal to 0. So we will be getting 15, it's total 25 I2 equal to 5. So I2 will be equal to positive of 5 by 25, which is nothing but 1 by 5, which is nothing but 0.2 amperes. So since we got I2, we can easily now find out what will be the VTH. So VTH will be start from A and again come back to B. VA minus VB will be VTH. Write all the potential drop. So what will the potential drop here? 0, because no current is flowing in this loop. Okay, come here. What will the potential drop? Plus it will be 3 of I1. Okay, since it's a potential source, again come over here. So I1 is nothing in this loop. I1 is nothing but what is I1 is nothing but minus of I2, correct? Because I am telling you that I2 is flowing like this, and I1 here I2 is flowing downwards. The same branch I1, I am telling the total current is I1, and I know I2 is flowing downwards. So I1 is nothing but same branch current but in opposite direction. So just a negative will come. Okay, so plus of 3 I1 plus of from up to down only one current is flowing, that is I2. 5 of I2, you write I2 or minus I1, it's your choice. Okay, plus of 10 I2, and I have write down all this equation and I will come to here. So this is my total potential drop. So this will be equal to VA minus VB. So it will be nothing but what is 3 I1? 3 I1 is nothing but minus of I2, minus of 0.2 plus 5 into 0.2 plus 10 into 0.2. So this will be V Thevenin. So it will be nothing but minus 0.6 plus 1 plus 2 will be equal to V of TH. Okay, so implies that VTH will be equal to 2.4 volts. So this is our VTH, and in order to find RTH IN, I will short circuit A and B, and I will write down the equations. So how to write down the equations after short circuiting? We will just, in order to solve for IN, in order to solve for I Norton or IAB, what we will be doing is simply short circuit A and B points. Okay, so we have just short circuited the A and B points, and we will find the current flowing from A to B, so that it will be equal to our I Norton. So now the current will flow in both the loops because it is a closed circuit over now, and we already find the VTH, so we will be now finding the IAB or the short circuit current I Norton. Okay, so let us already we have in the question given I1 and I2 over here. So let us this will be equal to I2 itself, the loop current, because this is the same branch current. In this branch I2 is only flowing. Okay, so this is the same branch current, so I2, and this let us suppose it be Ix. So let's form the equation. So now we will two loops. First write the equation of what let us write a simple equation first come first. What is the value of I1? So I1 is the branch current of this branch. Okay, so here Ix is flowing upwards towards the direction of I1, and I2 is flowing downwards in opposite direction of I1. Since Ix and I2 is flowing in the same branch whose net current is I1 towards up direction, so I1 will be nothing but Ix minus I2. Okay, so opposite direction of I1, and this is the exact direction of Ix, I1. So the same current, these two currents, the summation of these two loop currents will be equal to the branch current. Okay, so we got an equation I1 equal to Ix minus I2. This is Ix. Here I am telling that this is same as I2 flowing downside and Ix flowing upside. I1 is same as these two. So simply we write an equation first, and now what we will be doing is that write a KVL equation over here. So now I start from this point. Okay, and I am going like this, so it will be equal to 5 KVL at 1, KVL at 1. So I start from this point, go like this. So I am now coming from up to down. So up to down, which current is flowing? 5, this is the distance up to down. I2 minus Ix is flowing. Okay, so this is done. I2 minus Ix plus 10 I2 minus 5 volts plus 10 I2. So this will be our first equation equal to 0. Let's solve it down. It will be nothing but 15 I2 minus 5 Ix minus 5 plus 10 I2 equal to 0. So it will be nothing but 25 I2 minus 5 Ix minus 5 equal to 0. So from this equation, let's write one more equation first, KVL at loop 2. So if you write KVL at loop 2, then you can already tell that. Let's start from this point and again come back to this point. Okay, so minus of 3 I1 plus of what current is flowing from this to this. Let us assume I am going this from this side, so the voltage drop is nothing but my direction is positive, so the positive direction Ix is only flowing. I am wanting to write the potential drop this. Okay, so I into 10 Ix, which is Ix into 10. Okay, now no potential drop over here. Now on again minus of 10 I2. Then again if I go up position, so now what current is flowing? Ix minus I2. Okay, so plus 5 Ix minus 5 I2. I reached up my starting point, so equal to 0. So now it will be simplified as minus of I2 minus of I2 minus of 15 I2. So minus of 3 I1, and it will be plus of 15 Ix equal to 0. Okay, So it was so simple. Now we can eliminate ix. We can find out, we can eliminate ix with this equation. So what is ix from here? Ix equal to I1 plus I2. So just randomly write 5I2 minus 3I1. So plus it will be I1 plus I2. Okay. So in short, 15 I1 plus 15 I2. Okay. So now you can see I2 will cancel to minus and plus. So it will be nothing but 8 equal to 0. 18. So it's simple like that. So 12 I1 equal to 0. So we got I1, the net current, equal to 0 at this branch. The net current of this branch is 0. If I1 equal to 0, then it's nothing but Ix will be equal to I2. Okay. So you put Ix equal to I2 in this equation. So what you will get? 25 I2 minus Ix equal to I2 minus 5 I2 equal to minus 5 equal to 0. From here you will get the equation as it's 20 of I2 equal to 5. Implies that I2 is coming from this equation. The I2 is coming to be I2 equal to point of 5 by 20. So it will point of 5 amperes. So we can also tell that I2 is equal to Ix. So it will be also equal to Ix also. So Ix is only our IAB or our Norton current. So in short, we can tell that we already find IN, we already found VTH. So we already found VTH in this equation. So IN is equal to 0.25. So RTH will be nothing but VTH upon IN, which will be equal to 2.4 upon RTH. RTH or R Norton in this case, because we are solving a Norton circuit, Rn will be equal to 2.4 upon 0.2, whose value will be coming around 9.6 ohms. Okay. So this will be Rn equal to 9.6 ohms, and the current IN will be equal to, IN was 2.25 amperes. So this will be our resultant Norton circuit. So this is how we solve a circuit with a dependent source of Norton. Okay, in Norton circuit. So we have another problem, and we want to convert this circuit into a Norton's equivalent circuit, and this has a dependent current source which is depending on the voltage of 2 ohm resistance. So we want to convert it into a Norton's equivalent circuit. So we will follow the same steps as of previous question. So this is I Norton, this will be R Norton. So first step is to find VTH. Now look, how to find VTH is that, now this is an open circuit, so no current will be flowing here, and here two currents will be flowing, one is I1 and one is I2. Let us assume I1 and I2 like this. Okay. So now what will be the VA minus VB, which will be equal to VA minus VB. Now I have to somehow route the potential difference point, this point from to this point, and I can't follow this path. Why? Because the current source is there, and current source has a hidden potential difference across it. So what we can do is we can follow a super mesh. We can see this is as a super mesh, and we can follow this circuit and to write this KVL equation. So KVL equation at super mesh. Okay, it will be, so no current is flowing here, so 0 into 20, no current, because in this loop current is 0, like this, and this is 5I1 plus 5I1. So I am going up to down, and only I1 is flowing in this direction. So in my direction the I1 is flowing, so it's positive 5I1, plus I am going from this point to this point. So here the net current is I1 minus I2. So it will be equal to 15 I1 minus 15 I2 net current. So it will be I1 minus I2 into 15, plus here I am going from up to down, and plus of Vx is nothing but the current is in opposite direction of my assumed direction. So it will be I2 minus of I2 into 2, because I am coming from this point to this point and going like that, but this point to this point nothing but opposite of I2 is flowing. From this to this, if I say plus I2 is flowing, so from this to this minus I2 is flowing. So it will be nothing but minus I2 into 2. So it will be minus I2 into 2 equal to VTH. So upon solving this, we will have 20 I1 minus 20 I1 and minus 15 I2, 15 and minus 17 I2. This is 20 I1 and this is minus 17 I2 equal to VTH. So I2 is nothing but, I am assuming that I2 is flowing in this branch I2, and it's already given the 2 ampere is flowing that side. So I2 is nothing but 2 ampere only, but in opposite direction. So I2 will be equal to minus of 2 amperes. And how to find I1? So we already know that this is the direction of I1, and in this branch a 3 Vx current is fixed. So I1 is equal to nothing but 3 Vx. And what is Vx? Vx is nothing but, Vx is nothing but from this point to this point, plus of Vx is equal to nothing but, the current is of opposite direction. I am coming from this to be positive, and the current is flowing this to this. So it will be minus of I2 into 2 in simple. Okay. So put I2 equal to minus of 2 amperes here, and I1 will be equal to 3 of Vx, and Vx is equal to minus of I2 into 2. So minus of I2 into 2 is nothing but plus 4. So 3 into 4. So I1 will be equal to 12 amps. Okay. So minus of 2 into minus of the Vx will be nothing but my I2 is nothing but minus 2. So minus cancel out, 2 into 2 4. I put it here, and I2 I will put here. So it will be nothing but 20 into 12 minus 17 into what is I2 minus of 2 equal to VTH. So VTH I got this 240 plus 34. So it will be equal to 274 volts. So I got VTH. And now what I will have to find is the short circuit current. If I short circuit this, okay, what will be the IAB or Norton current? Since when I will find the Norton current, I can easily find the RN value. Okay, I will divide the IN value from this VTH value, so to get RN. So now the current will be also flowing in this loop. Okay, you understand, since it is a closed loop now. So I1, I2 and I3, all the currents will be flowing. So we will be writing equations of the 3. Okay, you can see the circuit over here, and we will write the equation. So now we have already drawn the circuit again, and we have short circuit the point A and B, as we already discussed in this point. In the same circuit, we have just short circuited the these two terminals in order to find the value of IN, which is equal to IAB. Okay, AB equal to IN. So how to find the value of IN? We will use KVL first. All the 3 loops will be having a current. Let's assume the currents first. I3 will be flowing in this loop. Okay, in this loop, let us assume I2. You can assume any direction as your wish, and this will be equal to I of 1. Okay, so now how will I solve the problem is that first I will write down the value of, this is 3 Vx. Okay, this is given only 3 Vx, and this is Vx, and this is 2 ampere current. So first equation I will get is I2 will be equal to 2 amps current in assumed direction. You can assume anything. If you assume like this, that I2 will be equal to minus of 2 amperes. Okay, nothing else. In this assumption, I2 is equal to 2 amps of current. Okay, and now in this equation I can write KVL, but I can write a branch equation. 3 Vx current is equal to nothing but I2 is coming like this, and I3 is coming like that direction. Okay, so according to my assumption, what will happen is that nothing but 3 Vx will be the upside current, because it is going upside 3 Vx. It will be nothing but I3 minus I1. This will be another equation. Okay, so this is one. This is not proper equation. This is one proper equation, because I2 value you can get. So here I want to eliminate Vx also. Okay, so what is the value of Vx? So plus of Vx is nothing but from this point to this point I am coming, okay. So either I get the plus sign Vx. So from this point to this point, what is the net current flowing? It will be I2 minus I1. It will be nothing but I2 minus I3, sorry for that. I3 is going like this and I2 is coming like this. So I2 minus I3 into resistance, the voltage drop Vx equal to 2 into I2 minus I3. You can put in this equation. So you will get, if you put here, you will get 3 into 2, it will be 6. 3 into 2 I2 minus 2 I3, okay, equal to I3 minus I1. So if you solve, it will be 6 I2 minus 6 I3 equal to I3 minus I1. So taking all that side, it will be nothing but 6 I2, okay, it will be nothing but minus of 7 I3 plus I1 equal to 0. So this is one proper equation you can get, okay. And if you write a equation in this super mesh, you can write the super mesh. I am starting from this point, I will go like this, I will come like this, okay. I will get a equation of KVL in this loop also, with this super mesh also. So if I write, this is the super mesh, if you can see, this is the super mesh. If you can write the equation, start from here. So it will be I3 is flowing this side, I am going like that side, opposite side, 20 into minus of I3, okay. In this area, it will be minus of 5 I1, because I am coming from this point to this point and I1 is flowing in upward direction, only current. So in this case, it will be plus 15 of, I am coming from this side to that, this side to this side. So it will, I2 is flowing this side and I1 is flowing opposite side. So 15 into I2 minus I1, and from here to here the Vx equation, from here to here the drop is Vx only, which we also write I2 minus I3 into 2. So this is, so plus 2 I2 minus 2 I3, and we reached our destination. We completed the loop, okay. So voltage across a complete loop is equal to 0. So it will be nothing but minus of 20 I3. It will be nothing but minus of 20 I3, and here it will be 20 I3 minus of 5 I1 plus of 15 I2 minus 15 I1 plus of 2 I2 minus 2 I3 equal to 0. If you write the equation, okay, I am writing here so that you can understand. So it will be nothing but minus of 20 I3 minus of 2 I3 minus of 22 I3, and here is minus of 5 I1 minus of 15 I1. So it will be nothing but minus of 20 I1, and here plus of 2 I2 and 15 I2. So plus of 17 I2 equal to 0. So this is the equation. This is your first equation, this is your second equation, and this is your third equation. So upon solving these three equations, you will get the values of current. You have three equations, okay. You have first one equation, two equation, and these three equations. So after solving these equations, you will get a value of, you can say that you can get the value of I1 to be equal to, the I1 to be equal to, it will be equal to, the I1 will be equal to minus of, the I1 will be equal to minus of 0.16 amps. The I2 will be equal to, already we have done 2 amperes of current, and the I3 will be equal to, our assumption was I1 was this side, I2 will be just equal to this is the equation, and I3 will be equal to 1.69 amps. You can easily solve these three equations. How you will be solving these three equations? Nothing, we have three equations, three variables, okay. So you can easily solve these three equations to get these answers, okay, using matrix or any other form of solving. So we know I3 is flowing from this side to this side as per IAB. So IAB is equal to the same branch current as of I Norton is equal to I3. So equal to 1.69 amps, okay. So what will be the value of Rn? We have already found the VTH value in previous page, that is equal to 162.13 upon 1.6. Sorry for that. Sorry for the equation, wrong equation. So the Rn value VTH was nothing but 274 volts actually. So the Rn will be equal to 274 upon 1.69, which will be equal to 169. Okay, which will be equal to 162.13. You can use a calculator to find this out. So Rn value we got, Rn value we will be equal to 162.13. So our Norton's equivalent circuit will be nothing but current we already found. It will be nothing but 1.69 of amperes. Okay, and the Rn value equal to 162.13 ohms. So this is how we solve Norton's equivalent circuit when a dependent source is present in the question. Thanks for watching. Do subscribe my YouTube channel.